Hello there. So let us look at the C operator precedence, lecture 2. So we looked at several operators. We know there are 45 operators. So whenever we discuss about operators, there are certain things that we have to look at. The first thing, whenever we look at an operator, the operator has to be discussed with something called its operand type, then its precedence, and something called associativity. These are three important terms that we have to look at. So what is the meaning of an operand type? Um, if you look at the operand type, the operand type has to be a legal operand on which the operator can operate. This is important. We'll see each one of them later. Then we look at precedence, which is nothing but priority to the operators. So it means if two different operators are part of an expression, they get evaluated based on the operator priority. If you look at associativity, now the meaning of associativity is if two operands have the same priority, then the order of evaluation is decided based on its associativity. It's very important. Okay. The associativity can be either right to left or left to right. So what is the meaning of left to right or a right to left? Which means if I have an expression, for example, suppose if I want to look at what is right to left. Okay, so if I have an expression like say 10 plus 20, right? And then you have equal to a equal to something like that. Now, if you look at this expression, it has two operators. This is equal to and plus. So plus has a associativity of left to right. So like this. And suppose if I have one more operator called 30, and the associativity here, I have two pluses here and I have negative here, I mean equal to here. The associativity of plus is from left to right like this, and the associativity of this assignment operator is from right to left. Okay, the evaluation will now depend on the priority of equal to and plus, whichever has higher priority gets evaluated first. So this is the meaning of something called left to right or right to left or right to left or left to right. Okay. So from now on, whenever we discuss about an expression, we look at what is called the operand type, the precedence of the operator, and the associativity. So let us take first to start with a very simple, pleasant example. For example, let me print the value of a expression which results in an integer. Okay, so we will say the expression value is percentage %d. Then I will say what 10 plus 20. This is a very simple expression wherein it's an arithmetic operator, as we know. Two operands are integers, so arithmetic operator plus knows how to operate upon two operands 10 and 20. So result will be definitely 30. So you may feel this is not a very complex example. We have to start with simple examples and then let us look at the complex examples. Okay, so we have 30. Now if I have one more 10 now, okay, now our understanding of this expression is, how does this actually work? Am I actually trying to look at something like this, or I am trying to say that it has to get evaluated wherein first 20 plus 10 gets evaluated first? So this is the problem, this is the ambiguity. Of course in plus it may not make any difference. Now if I replace that by a division operator, it really makes a lot of difference, isn't it? So maybe a multiplication or maybe a sub expression, right? So we have to verify that. So our discussion now is, I have three operands and I have two operators which are nothing but have something called plus and plus, right? So let us now try and look at the priorities of all of this. So what we will do now is, we will look at the operator we can have this habit of looking at. Our template that we want to follow is, now we look at operator, its precedence, and its associativity. First, let us look at what is the operator that we have in this expression. We have plus. And what is the precedence of plus over plus? They have equal priority. Okay. So, equal priority. And then, what is the associativity? Left to right. So, which means my expression will be now evaluated as 10 plus 20, which is 30, plus 10, 40. Okay. So, this is what I mean by evaluation of an expression. But there are certain cautions that I want to look at. Now, suppose in this case, if I have a sub expression which have equal priority, the evaluation of whether this gets access first or this gets access next and then it adds, or this gets evaluated first if it is sub expression, or this gets evaluated first if it is a sub expression of equal priority, is not guaranteed. It depends on the compiler, okay, which we will see later. So this is an extremely important point that I have said. Okay. So let us now look at one more expression. Let me copy this expression. Now in this case, I will take an expression which I will say 10 plus 20 divided by 10. Now if you look at this expression, right, I have two operators, plus as well as division. So for that we need to really have the reference, what is called the reference table, to understand the priority. Okay, so we may not remember that. So let us go and try and look at a file. Okay, so this is our reference operator. So we need to have this precedence of operators. It may be difficult for us to remember. For example, let me look at the relationship between plus and star. So if you look at this, in the table, this is the higher order of priority. This is a higher priority and it comes to the lowest priority, which is a comma operator. So my division operator has higher priority compared to my plus and minus, but luckily even division operator is left to right, which means if there are two division operators, the evaluation happens left to right. So let me go and look at our code. So now what happens is we have two operators plus and star and the plus and division. So one has low priority, the other one has high priority. I'm just doing the mapping. And then of course the evaluation is left to right. So first what it will do is it will do 20 by 10. Okay. Now 20 by 10, if two operands are integers in C, the result will be an integer. So which will be 2. And then the 2 gets added to 10, which is 12. Because if I do 10 plus 20 by 10, the answer will be 15. So we get a different answer if you do not know the precedence or priority of the operator. So let us try and execute this code. That may be because of our comment. Okay, so so if you look at now, this is 40 and this is 12 because that is how it got evaluated. Now again, suppose if I have in one more expression. Now if I have an expression like this, wherein the expression is say 10 star 20 divided by 10. So now I have equal priority operators again. If you go to my precedence table, my star and division and modulus operator have equal priority, but they are evaluated from left to right. So in this case, both have equal priority. The evaluation is left to right. So how does that happen? First it will do 10 into 20, which is 200, and then it divides by 10, which the resulting answer will be 20. Okay, it may not make any difference now because if you may say, sir, y by 5, even if I do 20 by 10 is 2 10, so 10 plus 2 is 20. How does that matter? So if I do 10 into 20 is 200 by 10, it may not make difference here, but if it is sub expression, there may be an issue, right? But let us follow that procedurally. So we have now, I think we did not save the code. All right, so now our evaluation is 20. Okay, but now we have, when it comes to say plus or minus, they tend to be a little bit polymorphic. Now polymorphic, which means is many forms. Right? So what does it actually mean? For example, how does the compiler know that I am looking at say minus minus like this? All right. So when I give some expression like this, if I go look at my table, right, my table also has a minus minus operator. My table also has a minus operator. My table also has a unary plus and unary minus. So how does this compiler actually look at such an expression now? Is it looking at 10? Is it looking at these two as double equal to? Or is it looking this as 20 minus of minus 10, which is 20 plus 10? Okay, so this is a very tricky scenario. All right. So if you try and look at this right scenario, what is it doing? It suddenly takes that as an increment operator. See, that's the problem. Okay, what you thought as minus of minus 10, we have a problem. So let us give a space here. Let us see if that is going to make any difference at all. Okay, so now it sees blank spaces, right? So you know the difference between a blank space and a white space. Now white spaces, this is all our white space, but in an expression this blank space is processed, it is not ignored. It is used to differentiate between the two tokens. Now let me save this and see if we have any respite into this, right? So Okay, so now it's fine if you see, isn't it? So if you now look at something like this, right? So how did the expression evaluate got to be 40? Okay, wherein this minus of minus 10 became plus 10. So it is 40. So we have those issues there, isn't it? So if you look at now this minus is polymorphic in this scenario, which it has taken as binary because takes two operands, but this is taken as unary. And one more thing is, if I just give 10, then implicitly it is nothing but plus 10, wherein all positive integers we do not indicate any sign. Only if they are negative integers we indicate sign. Okay. I hope we were able to get the drift, right? So suppose let us take one more expression, for example. Now suppose if I have an expression like this. Uh, I have an expression like 10 into 20 by 40 plus 30 into 9. Okay, something like that. Now if you go by our typical uh, evaluation methodology, so we have a star, we have a division, we have a plus, and we also have a star. So if I want to now evaluate expression, the star and division have what is called the equal priority. So I'll start from 10 into 20, which is 200, then divided by 40, which will be 5. Okay, then 5 plus I have 30 into 9. So when I have 5 plus 30 into 9, this gets evaluated because star has higher priority. So it will be 270. Okay, plus 5. So the answer should be 275. Let us hope that we get the correct answer, or whether our understanding is correct, right? That's 275, isn't it? So, but I want to now suppress the precedence. It's not a question of suppress the precedence. Now, if I look at this, anything that is in the parenthesis, it may be a parenthesis or a function call, the associativity is left to right, but that gets higher priority compared to any one of it. I mean, what does that mean? So let me just go back to my code. So what it did 10 plus, right, 20 and then by 40. So what I want it to do is I will put this entire fellow in the bracket now. So when I do this, right, my 40 plus 30 into 9 becomes a sub expression, right? Now when it becomes a sub expression, this is taken as one sub expression and this is without parenthesis. The first thing that the compiler looks at it actually processes this, because whatever is in the bracket gets a higher precedence. Now suppose within this, if I have one more bracket like this, okay, then again I'll get what is called higher priority to this inside, which means the innermost parenthesis gets evaluated first. So our answer will be 70. Then 70 into 9 is 270. Okay. So I'm sorry, the 70 into 9. Now it has changed, isn't it? So 70 into 9 is 630, right? Now that 630, I would like to divide what is called 200 by 630. So our 200 by 630 should result in 0, because we have, when in C, when the integer operation gets divided, right, the answer is 0, because if in C language, if A by B, if both A and B are integers, right, and if A is less than B, it always results in 0. This is very important. Okay, so this is what, in a nutshell, the evaluation of expressions, lecture 2. We look at other expression evaluations along with other operators in the subsequent lecture videos. Thank you very much.